Welcome everybody to the sort of last presentation of today. Appreciate it's the graveyard shift. We'll try to get through it as quick as we can for you. Myself and Craig are here today to talk about the major piling schemes we've undertaken in the last sort of control period. So, it tells a story. We've been on the CP6 framework in capital delivery for the Eastern region. In this sort of 5 years we're up to now, we've delivered over 30 earthwork solutions with a mixture of everything from regrades through to cess retention, and then sort of the main focus of today in regarding major piling solutions. Over the course of CP6 and the works we've done, we've realised that our supply chain have learnt things, we've learnt things, and sort of the purpose of today is to share that with yourselves so everyone else can take that knowledge and sharing. So the sort of 4 key schemes for us to focus on was the first sort of scheme we did in Hessel, back on the Humber Estuary, near the Humber Bridge. That was delivered in 2019 to 2020. We then sort of going to touch on Gulka, what's another scheme between Huddersfield, to the west of Huddersfield on the Manchester to Leeds line, delivered 2020 to 2021. Then sort of the 2 biggest schemes and probably more focus of the presentation, one regarding Morpeth, what's been briefly touched on in the photo we used earlier, what happened 21 to 22. And then finally Brownie Curve, a scheme that probably most people in the room may be aware of, what we started in the sort of September time. I'll now hand over to Craig, who's going to take you through Gulka and Hassler.
Thanks, Ed. So as you've just seen, Hessel was the first major piling scheme undertaken by Storey in CP6. The railway at the site runs alongside the Humber Estuary, and as with all sites that we've seen today, it's typically a convoluted history of maintenance and intervention that you associate with aged railway infrastructure. So the recent history at Hessel looks a bit like this. Historical works were taken to stabilise the foreshore in around 1998, including rock armour, sheet piling and a concrete retaining wall to retain the Trans-Pennine Trail that runs alongside the railway location. Then about 20 years later, a scour hole formed in the estuary itself. This led to the rock armour falling away with rotation of the sheet pile wall and the reinforced concrete wall. Emergency works were undertaken in 2019 to stabilise this with rock armour and new rock apron, and they were largely successful in arresting that movement. And this is where Storey came in, and we were instructed to design and implement a permanent solution to support the railway and the footpath. Slide. So, following an optionary selection process, decision was made to install a contiguous board pile wall to stabilise this section of the embankment. The solution was preferred due to it being able to be undertaken off track and without the need for rules of the road possession, or without the need for possession working. The design relied on tying the new board pile wall into the existing sheet pile and the reinforced concrete wall using a new pile cap. And the existing Trans-Pennine Way proved a suitable but constrained working area for the piling. The delivery of the scheme required detailed planning with our specialist subcontractor Keller, who had also recently commissioned 2 new narrow footprint rigs to undertake the works, whilst still being able to install segmental augured CHS piles to the required diameter and toe level. Further challenges were imposed at this site by the weather conditions working in the estuary, and the site works had the poor fortune to be coincident with the first COVID lockdown. But despite the challenges, the works were successfully delivered. So one of the key things that's probably driven through Storey's experience at Eden Browse and taken to this site was the timescale for welding the CHS sections on site, and it was basically we determined that there'd be large efficiency gained by trying to remove the requirement for welding. So mainly at Hessel, due to weather-related disruptions to welding, and also the welding activities limiting piling productivity. So the aspiration was to remove all welding and utilise a threaded joint for the pile casing and reinforcement. Storey, Keller and Paul Krieshman worked together to develop several different welding options and threaded connections. Destructive testing on the joints was undertaken at the University of Sheffield Advanced Manufacturing Research Centre. Unfortunately, testing revealed that welding couldn't be removed, but what it did lead to was development of a trapezoidal threaded connection in conjunction with a single pass weld that provided a suitable structural connection, and it also reduced welding times in half compared to the existing practices. So they were taken forward, and that was the welding that was used on site. So the second scheme that Storey would be involved in was at Gulka. This was another emergency scheme. It was located on the Transpennine Huddersfield to Manchester line that serves Manchester Airport. Initially, the scheme was reported as a burst water main and washout by a train driver. And then on later inspection, it was revealed that the water main had been displaced by a historic landslide, the scarp of which you can almost just make out coming through in the blue line, and the access track itself has started to drop. There was also evidence of movement in the retaining wall that supported the access track up by the railway. Should come up there, you can see the movement in the retaining wall. So, again, Story initially undertook a ground investigation comprising road record boreholes at the head and toe of the landslide. Monitoring instrumentation was installed, and landslide movement was recorded along the interface of the weathered bedrock and the overlying deposits. So the ongoing movement and the emergency nature of the works meant that there's a much shorter duration to undertake design development, so option selection and design were expedited in this case. And again, the chosen intervention was a contiguous board pile reinforced concrete wall, utilising circular hollow sections again in a 600mm diameter bore. The wall was positioned as a balance between the impact on the operational railway for piling operations, so we could work adjacent line open, but also the retained height of the design. And due to the higher structural forces and the location of the slip at Rockhead in this section, we weren't able to use the threaded and welded connection. But so at this site we had to use couplers on the CHS steel. But then taking these two sites in balance, and we move forward now into Morpeth. So Gareth stole a little bit of our thunder with some other slides, and we did wonder what we were going to say. So we'll carry on, but everything seemed positive. So Morpeth embankment, we completed construction of this site around about a year ago. It's another emergency scheme and another site with a convoluted history of intervention, monitoring and management. The picture at the right represents the situation at the site. The main thing to note is historically the site would have presented itself as an embankment to both sides, albeit a low height embankment to the upside, which is where you can see the container yards situated. That area was filled in sometime around the 1970s, 80s, and that's when the problems were first recorded at the site. Over the next 40 years, various interventions were attempted to mitigate the stability and drainage issues at the site. And then in late 2020, a series of deeper boreholes and monitoring instrumentation identified a much larger hillside failure mechanism. And you can just see the back scarps conjectured there across in the East Coast main line. And being as we're at PWI talk, there we go, we'll get some track on picture. So we can see, I think you can see then there's typical failures alongside the rail. So sorry, the previous two schemes we talked about were typical failures alongside the railway. But this one, as you can see from the sags in the picture, the failure surfaces clearly be identified going across all four lines of the East Coast main line and into the displaced fence line on the upside by the container yard. Issues had also been experienced with the Ole headspan gantries at the site, and these were due to be replaced with a pole frame gantries in a sister project to ourselves that was running concurrently alongside, so they could increase the maintenance of those structures. So what does that look like in section? We all like to go cross-section, don't we? So there we go. So typically the failure mechanisms identified by the deeper boreholes revealed this tripartite system of glacial till laminated clays and sand and silts overlying the coal measures bedrock. It's a deep-seated translational landslide and a secondary shallower rotational landslide that were picked up by the monitoring instrumentation. There's also a series of steep-sided hummocks and groundwater seepage at the toe of the hillside that represents the toe of the primary landslide. High groundwater levels within the stand and silt overlying the glacial laminated deposits are considered a prominent driving factor. So that sets the scene. Ed will now take you through the works he helped implement on site.
Thanks, Craig. So as Craig previously showed with the photo and the track, that occurred in the February of 21. Story mobilised in the following October to implement an interim solution at first, which consisted of some temporary sheets, what you can see in the bottom of the photo on the far left-hand side. Sorry, it's your right-hand side, isn't it? So apologies. And then sort of there was also an interim bit of work to try and relieve poor water pressures, both of which was done prior in the winter of 21. So the two photos, the one on the left is showing the leader rig installing the 144 sheet piles. These are at the toe. Not only to provide sort of some tone restraint for the winter it was sort of looming, but also to facilitate the site to take the wider temporary works we need to install. The second photo on the right is showing the incline drainage getting installed, and the whole purpose of this is to try and keep water levels down below a critical level, what would cause further railway movement. This ensured the railway could stay operational while the wider materials were procured. So part of the permanent sort of solution, the permanent works consisted of 2 sets of double twin row pile walls, one located at the toe of the ash embankment, which was regraded in 2016 prior to the site, and then the second set on the mid slope further down the site. In total, 207 sheet pile, CHS tubular piles were installed at 750 diameter, 132 on the upper and 75 on the lower. So during the design and development, something that the project team managed to secure a stock of non-prime steel. This was located in Thirsk. The tubes then were required to be threaded, ready for the sort of jointed connection Craig's mentioned on his previous slides. Given the site constraints and the available stock, tube was sourced at 12 metre lengths, so it was cut at 12 metre length in Thirsk, sent up to Glasgow for threading, and then delivered back to site in 12 metres with a threaded connector. This was then threaded on site and welded together with a single pass weld to reduce the construction time as much as possible. At that point, a 100-ton crane would lower the tube into the formed rotary bore holes, and then about 13 cube of concrete was poured into each pile. This process was repeated throughout the whole scheme. Something on the back of this, we believe that over 950 tonne of embedded carbon was saved from using non-prime compared to prime steel. So the photo on the screen shows the extents of the site when piling operations were ongoing. As you can see, there's circa 14,000 tonne of stone placed on site was a recycled 6F5 material. This was primarily used to create the 12 metre mats on the top of the photo, and also the 1 in 10 grade haul roads. The site originally was about a 1 in 4 in parts, so there's quite a bit of earthworks to be done sensitively on site to ensure we can get plant and equipment up there. The link on the screen does show a wider video for anybody to watch after the event. So sort of the key lesson from all our piling schemes is about collaboration and early contractor engagement. Part of getting people on board early is ensuring that the piling subcontractors and the temporary works designers and the permanent work directors can all work collaboratively to pick the most sensitive solution for both working on active failure whilst keeping their operational railway above operational. Another sort of point of note to everybody, and especially if you're going down the non-prime or a little bit different route rather than ordering stock steel, it isn't secured until you physically purchase it. So it does mean there has to be flexibility in the design, and that sort of flexible working has to be done by everybody, and everyone has to buy into that because the design will change and be iterative as you progress the site. Obviously, given the nature of the site and Craig's photos and everything else, from us mobilising, there was a temporary speed restriction on, so a lot of work was having to be done in managing the stakeholders to keep everyone in the loop. As we do work, so you will experience more movement, but in the end you will get your common goal of the operational railway running again. I'll now hand over to Craig to run through Brownie and some further takeaways.
Thanks, Ed. So the final project just want to discuss today is a scheme where we started on site a couple of months ago now, just taking in our initial enabling works. It's called Brownie Curve Embankment. It's probably well known to a lot of people in the room. And the main difference to the other sites is that this was a planned renewal scheme, not an emergency scheme. So we spent probably the last 2 years designing and developing this scheme and getting the necessary funding and getting to site, which has been a challenge in itself. It's not being progressed under any emergency or expedited delivery route. And as you can see from the slide, the site's been causing maintenance issues ever since it was constructed. So, roughly speaking, Brownie Curve, or Gill Bank as it's known, is located on the East Coast Main Line just south of Durham. And the railway is carried, the twin track railway, overhead line electrified, is carried on an embankment across a natural hillside that's impacted by several active landslides. So, quick annotation of what those active landslides look like. Landslide 1 is the main deep-seated landslide complex interacting with the railway embankment itself and the lower hillside. The toe of the landslide daylights in the banks of the River Brownie. Groundwater levels, material properties of the underlying ground, and erosion along the river all contribute to the landslide development and movement, as well as the loading, obviously, from the railway when it was constructed itself. Landslide 2 affects the upper hillside between the railway and up to Brownie Lane above, B6300. And the main impact of that landslide is the deformation on the toe drainage that's installed. It doesn't look like it, but it's actually an embankment on the other side, on the downside to the left of the picture, your left. And the impact of that landslide is that it damages the tower drainage that collects a lot of the surface water runoff and carries it through the embankment. And the head of the landslide also impacts upon Brownie Lane, although Durham County Council have recently undertaken some works to resolve their issues. And then we've got what we call landslide 3, which is the most active part of the site. At times it's moving probably up to 100 mil a week at the minute, and we're looking to unfortunately it's our main access route into the site, so we're coming in from the bottom right of the image across landslide 3 to get into our main piling platforms. So we're just undertaking some enabling works at the minute so we can work our way past landslide 3 or float atop it. This slide outlines how the landslides are presented in a section. So landslide 1 is there's a failure surface up to 16 metres deep below the embankment crest, reducing to around 6 to 7 metres deep down the hillside. Landslide 2 is typically much shallower, about 4 metres below ground level at its maximum. And the ground conditions are very much as described at Morpeth. Got tripartite system, glacial till overlain by lacustrine laminated clays, or glacial fluvial deposits overlying glacial till. So, bit of a busy slide, bit of a busy image. You might not see what's on there, but following the optioneering and development process of the outline and detailed design, several different solutions are required to mitigate the landslide movement and the impact upon Network Rail's infrastructure. Landslide 1, the solution will utilise multiple rows of space piles, similar to what you see at Morpeth, to stabilise the landslide with embankment regrading to reinstate the embankment shoulder that's been lost over time. Landslide 2 measures are going to comprise pretty much groundwater level control with tree planting, slope drains, drainage repairs, and some sheet piling at the toe of the landside to protect the existing deep drainage system that's in place. This slide shows it very similar to Morpeth, shows it in section. And you can see the spaceboard power rows, 18 metres long on the lower row, 25 metres long on the upper row. It also gives you an indication of the size of some of the piling mats that we're having to put in places to implement the works. The space piles are again 750mm diameter bores, reinforced with 610 CHS sections, threaded on site and welded on site, similar to Morpeth. The wall thicknesses are subject to non-prime steel stock availability, so we've gone through quite an iterative design process of attending what stock's there, taking a design, going back saying this is the stock we want to supply, and the stocks have been sold. So we go back, what stock have you got now? Right, okay, so another design process. So it's taken a bit of time, but we've got there, we've secured the stock we want, and so yeah, what else? Planting is going to be used to manage the shallow stability on the upper hillside, due to surface water runoff, and also to help mitigate some erosion protection at the toe of the landside by the River Brownie. There's no works required at this site to the overhead lines because they've already reached their end of their life, and the single track cantilevers became unserviceable in 2019, and they were replaced with twin track cantilever structures that were situated behind the main landslide. I'm going to quickly go through this next slide. Probably one of the most important slides as well, but one of the main challenges we've had at Brownie as we've gone through the design development is the enabling works, making our way into site, and we're only in the enabling works. There's no pictures of piling rigs at the site, unfortunately, at the minute. One of the main issues we worked through is the temporary sequencing with the designer. We engaged our permanent works designer to be our temporary works designer because they could use their 3D finite element analysis and their limited equipment analyses, sorry, I always get stuck on that word, to model the impact of the piling platforms and the construction sequence on the landslides. We've established early supplier engagements with, and also engaged via capital delivery with Network Rail maintenance, because the key interface with the track maintainer is, and a key thing I'll say is, this site is moving and has been moving for 200 years. The maintainer is maintaining it. Our works will increase that movement, so Network Rail have implemented a proactive maintenance regime and increased their number of maintenance tamps. So I'll just quickly run through the next slide. It should be automatic. This is our sequence in our fancy 4D software that's called Me and a PDF late at night. And so essentially, this is where we are at the minute now. We're sheet piled our way in. We'll work our way in piles on the lower hillside. Sorry, it's get the piling platforms on the lower hillside first. Once they're in, we then start coming back through and starting our piling to the lower hillside. We have to install all the piles on the lower hillside before we can start piling on the upper hillside. And then we work our way down to the most active area of landside 1, which is to the low mileage end. And eventually we start following on with a regrade behind. And then it all being well, we're then able to start building piling platforms in the most active area of the site, with a lot of the works complete. And then eventually in December 2024, don't hold me to that, we will finish all the works, the pylon will be complete, and landscaping will be done. I'll quickly mention monitoring. We've got 6 active total stations that we've just established at site, readings every 2 hours, early engagement with TME over maintenance. There's been a very good engagement with capital delivery through Project ACE, that we've engaged with works delivery to supply the power to our total stations, which probably would have taken us months to do when we got that in within a few weeks. And also that Network Rail being able to have preemptive discussions that we've supported with the Tox and Fox so they can understand the issues at the sites. So very quickly, key lessons learned, last slide. Sorry, I've just lost my notes. Here we go. So start big, start early and plan big. Ideally, we'd love to keep the works to a minimum, but what we've found on some of these sites is due to the scale of the landslide and the size of the pylon equipment we need the big plant there. And so I just put it out there, 20 designers, any temporary works designers out there. When we approach a pylon contractor with a 5 metre wide pylon mat, there's not much plant that they can get onto the site. So we've now moved on, and we're actively managing these landslides and putting large pylon platforms on them. There's nothing in here that's new. Most of this is probably just regarded as common sense. Working windows have been subject to numerous constraints from various different stakeholders, such as Durham County Council, Environment Agency. Sequencing's been key in this, in gaining trust from the work we've done at Morpeth, and gaining trust with Network Rail in terms of our designers, that they understand the hillside, it's been monitored for years, and that they can think they can manage this sequencing. And the buy-in from the TME in terms of the increased maintenance regime has been key. Recycled and non-prime materials, explore them during design. Even better if you can source local suppliers, because we found obviously transport costs a key driver in carbon savings. Build relationships with key contacts in the maintenance organisation, understand their world. It will help with the challenging conversations later on. And it can be difficult on actively moving sites to determine the cause of movement, especially when you're working during inclement periods. The site's already moving and you've got about 7 different activities on site. So a good period of baseline monitoring always helps. And also trying to understand the lag between what we're seeing on movement on the hillside or movement in the ground and movement at track level. And plan against any situations for pylon positions refusals, because pylon subcontractors have high standing charges, so keep them active as much as you can. And that's where we are. Thank you very much.